This conference will now be recorded.
Hope you remember our last session. We were talking about functions like talking about this one. What is that? About filter. I hope we had a discussion about filter in the last session. Let's continue other things. 1 minute, just a minute. Okay, let me get to that. That one. Okay, guys, let's get to the filter topic. We had finished it. It's a good session last time. Filter. These were the things we were talking, and I had explained about the postmortem of filter as well. Okay, you can see this how filter works, all that. We had a very detailed discussion in the last session, and now let's continue with map now. Okay, what map function does. I think we have to continue from here, right? I don't think we discussed last week. I tried to have a session, but somehow we were getting some noise. I am in the village, and all the buffaloes were going to the school at that time. No, right? When they were going school, village means every day people will send them to for grazing outside. In the cattle will be sent out for some time. But due to that noise, the session didn't happen. So we will continue from there. Okay. So now, what is the map function? It is something like this. All these are very important, even if you want to learn big data as well. If you want to iterate every element in a sequence of data and apply some functionality, then Python is offering a function called map. I had already explained like the behavior of map function somewhere in the previous session. Okay, how this map function works and the customized approach of map. Actually, I have taught you this. Maybe it might be there in some video session. Last before video session, there is a detailed discussion about map. You can go and check that. It will be very clearly explained there. Okay. So the point is, what this map does. Filter means it will apply when it will iterate each element from the sequence. Sequence can be a list or sequence can be a, what is it? It can be a tuple. Means some indexed data structure. Okay, that is fine. Even map also will do the same. But the difference is filter apply a condition and return that result. Whereas map, map just applies some logic on each element. Got it right? Some logic. It apply some functionality. You can see there. Understood? That's what map does. Got clarity about that, right? Following or not? It applies some functionality. Next one. As discussed in the last but week session, like all these three functions will take two parameters, a function and a sequence. function can be a lambda. We were talking about lambda functions, right? It can be a lambda or it can be a customized function. When you say customized function, it's nothing but function which you write by yourself. Okay, that is what customized function is. So when you see this, I have already clearly explained this scenarios. When we are discussing about this, which one? Filter. Almost the concept is same, but the way we use this, the behavior of map changes from filter. I have done a postmortem in the last session. How filter works. I am opening idle just for working on these things. Excuse me. Okay, let us save this somewhere in the put it in EDF. We have Python programs there. So here I am saving it, something like map.py, and now might be there is a built-in. Don't worry about it. It might get okay. Let me save it as. Otherwise, there is a possibility of getting confused with the map demo. Okay. Map demo.py. Now let's continue. 1 minute. Okay, now let's start understanding this. So now if you see this, I have a list of elements. This is without, this is a function which performs what it performs. On each element, it will perform some logic. So, and return that result. That's what this function is doing. And this map, filter, and reduce, all these three functions, all these three functions, what they will do, they will expect two parameters. One, a customized function, and second one, a sequence. So first you have to prepare a function which handles the logic, and that you have to pass as a parameter to map, and then the sequence. Sequence, this is the sequence. You can see the elements. The point is, whenever map function iterates, I told you, right, how the iteration happens. It will go to the sequence and it will extract each element one by element by element. First, it will take one and it will pass that one to this function sum. And sum will perform adding that 1 to 100. It becomes 101, and that is written and that is updated in the map. Like that, this functionality happens. Okay, so that's how the behavior is. Anyhow, I'll explain clearly while writing code here in the idle. So you can take some list here. First of all, some li equal to some elements of your choice. I'm just taking 1, 2, 3, 4, 5. Okay, these were my choice for now. Then after that, I'm creating a simple function just to find the sum of all the elements, sum of list. So you can take any parameter and you should pass a parameter to that sum x. And I'm saying return 100 plus x. Means every time that element comes to sum, what sum has to do is sum should add some 100 to that x and return it. That's what it has to do. Now you take map function, some result equal to some map of from list, comma, you have to pass the parameter, the sequence to that. We had a detailed discussion on such kind of requirement even in the last session. Now what happens here, how this map behaves, what this map does is every time what this map does is it's like an iterator. Internally it's an iterator, like a loop. It will take this sequence and it will iterate that element by element. First it will take one and apply and pass that one to this function, and that is passed here, and that is added to that is returned. It becomes one. Okay, similarly, once that is done, again it will move to the next value. Again, from the sequence it is passed to the list, this function, and function will add, it will go to here. Then that 100 is added to 2 and 102 is returned. In that way, it will iterate all this sequence of elements, and it will apply logic on each element. So that's what map does. If it is filter applies a condition on some, it will apply a condition, whichever is satisfied only they were written. But it is not like this. Map is not like that. Map applies a functionality on a logic on each element. Okay, now let's print it. We are done. Let's just print it now. Print of the result. Okay, save this. Just say run module. L is not defined. I don't know where is this. You have to put it as Li, not L. Put it as Li. Run module. I'm getting a map object. Nothing to worry. If you want to see the result, you can iterate this. Whenever you get output as such objects, there are two ways. Either you have to apply casting. Otherwise, you should iterate it using a loop. Following, I'll just show you here. See. So how do you apply using a loop? So for some I in result, then print alpha. Now run this. Can you see this 101, 102, all this? Otherwise, there is another way. This is getting extracting element by element. If you want all elements in one collection, then you have to apply a casting to this. You can apply casting to tuple or list, whatever you want, you can do it. Okay, apply a casting with tuple. Then all these elements will be appended to this list. You see, can you see this now? When I print result become a tuple, result become a list. I have appended to what is that? I am applying a casting to list. When I do casting to a list, all the elements are appended to the list, and then that is returned. Then what we have to do when you print result, what happens? You get all in the form of what? A list itself. Okay, click on OK. Can you see this now? And this is how it behaves. Got it right? That's how what is that? This will behave, guys. Following now? Following or not? Okay, next one. So that's about map function. Got clarity now? So for this we are using customized function. Suppose in place of that, if I am going to keep a lambda function, the point is that only, right? How to use lambdas in these built-in functions. These are all built-in. Which one? This map, this filter, this reduce, all these are built-in functions which perform some kind of implementation. Now let us see, if you are using lambda, you don't need all this. You can remove this customized function. You can directly prepare your function. How can you prepare your function? The syntax of lambda, right? LAM BDA. It's an instant function. Lambda some variable name colon. Then what should I do now? We have to increment this by 100 plus x. Okay, is it clear now? Or x plus 100, anything is fine, guys. Nothing to. And save it now. Let us see how the result is here. Can you see we got the same output? We don't see any big change here. Maybe if you are not convinced, sir, this output seems to be previous program output. So I'll do one thing then. I modified it to 200. Let me run this. Now, is there change in the output or not? Okay. I have explained clearly about lambda in the previous session, how lambda works, the behavior of lambda, everything. You can go and check that, guys. And also I have explained the internal behavior of a filter. Almost it is same for map or reduce with a bit of, even I have explained before moving to these functions. I have shown like how the behavior, the algorithm behavior with samples, okay, in the previous sessions. So you can go through those sessions if you want to have a deeper analysis of each and every topic. Okay. So that's it about map. We are done with map. Now we can happily switch to which topic? We can switch to the reduce topic. Also, there is one more important point. What is that point is we can apply a map function on top of multiple lists, but make sure all lists should have same length. That is very important. So I have list one here. You can see here. Can you see this example? Not the 9th one, 10th one. You have two lists here, but make sure the length of both lists are same. Otherwise, this is not going to work. This is going to fail, guys. Following right there. So what is the point here? You need to take two lists with same length, and then what do you have to do? It's almost same, right? You can see instead of one parameter, you have to pass two parameters based on your logic. It's not like we should be having one or two parameters. You might need sometimes 3 or 4 parameters also. It depends on the functionality. Understood? So here the point is you are doing the same here. You took two lists and then and you are trying to pass this to the map function. Map is going to iterate two lists at a time or two sequences at a time. So that what is that I am doing? I am trying to perform multiplication of elements from both lists. Here I am taking two parameters. X will use to copy element from L1, Y is used to copy element from L2. Then we are performing what is that? Product of both the parameters X and Y. And we are returning that. That will be returned and that is copied to the L3, which is a list, because you are casting to list. Then it becomes a list. You got it right. What do we do is let us just run this code quickly. Are you following, guys? Like, please just answer in the chat, okay, if you are following or not. Is it clear to all of you? All of you are clear? Okay. If any questions were there, you type there or you can ask me, because we have limited people here now. And most of you are known to me. You are not unknown people, okay? Because I see most of you attending our sessions. Agand and Ayappa, Deepak, Koti, Madhu, Rakesh. Rakesh, I am seeing new. And then Shiva, Vinod Krishnan. I think everybody are known people. Now you can talk to me, not an issue. Okay. Why, if we have in the beginning, because we don't have that understanding, I don't know who you are or you don't know who I am, there might be a bit of inconvenience, a disturbance, but now we don't have such issues. But anyhow, let me switch to my topic because this is very important. Are you good now with this? Do you understand? So means this can be applied on multiple lists as well. Okay, if you want 3 lists, you can take that. But the rule is all this list has to have same length. That is very important. You just run this, just say run module. It will perfectly work, no doubt about that. You can see, right? You can analyze the result of output also. There is nothing wrong in that. Okay, got it? Got it, right? I love you. So that's about what passing multiple list to a map function. Okay, next one. And one more important point. These are all very useful things. Okay, I told you all these materials are available in my GitHub. Okay, Lambda operator can have any number of arguments, but it can have only one expression. Means the logic expression can be one, but the number of parameters can be many. That is the point. Okay, so you cannot have multiple expressions like in functions. You can write as many logics as you want, but here it's not the case. What is the point here? Here you can have at most only one expression, but you can have many parameters. So for more detailing, if you miss it, I have uploaded all the sessions till date in the YouTube. You can go and check that. Now I am switching to the next function, reduce function. See, these are all important functions. People ask you in interviews as well. Trust me, sometimes in interviews, you know, when you answer these kind of things, the probability of selecting is more for you. Okay. Next, okay, that is done. Then reduce function. What is reduce here? Why do we need? Reduce is nothing. You already know that. You know how to find sum of first 10 numbers, right? We have done in the very beginning of Python sessions long back. What it does? Sum of n numbers. Simple. Suppose you have 5 numbers. Okay. When you iterate it, what happens? All the 5 numbers, suppose 1 to 5, you get 15. Means 5 numbers got reduced to one number. The total result become 15. That is called reduction. Okay. So we have already done such kind of reducing functionality in the beginning of our sessions itself. That is what reduce function do. Suppose you give 5 elements, 1 to 5, and you perform product. You get something from that 1 into 2 into 3 into 4 into 5. That is a reduction. Reduce is nothing but when you have more values and all those more values are again converted to a single output by applying some functionality. It is called reduce. Got it right? It is used to reduce sequence of elements to a single element by applying the specified function. I think that is clearly explained now. By applying some logic, group of elements from a sequence are converted into a single element, either by adding, by doing product, or by dividing, or something else like that. Something, some kind of functionality as per the requirement. So that is good. And what is the challenge part here is again there is no challenge. I am sorry, there is nothing challenge here. There are two parameters, same as usual, like how we have had for okay map and as well as filter. See, all these three functions have same number of parameters, and almost the functionalities and the behavior is almost the syntactical behavior seems to be same, but the functional behavior changes. The way they iterate or the way they apply the functionality changes. But the way we apply the syntax is same for all these three functions, and these are the most very important functions in Python. Okay. Okay, that is fine, guys. Okay, then what is the reduce do? I have clearly explained so far. Okay, but point is, whenever we are using reduce, if it is map or if it is filter, we directly got it. We directly used it in the code. We didn't import any modules. But if you want to use reduce, you should import it from a module. That is very important. Okay. And this module, the reduce is available in a module called function tools, func tools, technically, FUNC tools, and which should write. And here we have to use import statement. I'll talk about all this in modules topic. Okay. Might be after finishing functions, we might take up either files or either modules. We will explain. That is actually modules. We can close it in 1 or 2 topics. It's a simple thing. If you are from Java or C Sharp, it is like packages concept, but not exactly same, but a similar kind of this thing. So okay, what is the point? Reduce is available in this module func tools, and If you should use that, what is that you have to do? First, you should import it. What is that you should do? You should import that functions. Understood? So what do you do right now? Just just apply this. For now, you just follow this. Later on, I will explain why you should use from import. There are different types of imports in Python, but we'll talk about it later. This is not the time to discuss that. Just remember, you have to import any module like this. Okay, if we should do it using from approach. Okay, import star means everything from this module function functools. Okay, once you do this, same process is same again. Okay, then what you have to do? It will take two parameters. One is a function, the other one is sequence. Now we are always trying to understand the behavior without lambda, with lambda. Without lambda, you write a customized function like this. To do the detection, you are just doing like this. What is that? You are taking two parameters to the function. Okay, and then what you are doing, you are adding two at a time, and you are exchanging the elements from B to A and C to B. It's more like Fibonacci series logic. Okay, because you are trying to add two elements, right? And based on that, your logic has to be applied. I taught you Fibonacci also, right? How to implement Fibonacci series. I don't exactly remember long back, but we have done a lot of logics. I still remember. Okay, so this is the point. Are you guys testing? Testing what I am trying to execute all here. Okay, otherwise you test it after this. Okay, then we'll run this now. Now you have to pass this add function to this reduce and this list to the this one. Then what it will do, it will take element by element and do the reduction. All the elements are reduced here. Following, right? Into a single element. We'll just now copy this and paste it and check it out. I have clearly explained in the last class with the postmortem the behavior of all these functions. Okay, so I have written a customized function and we have tested everything. You can try that now. Reduce is not defined. You know the reason why it is throwing error. Why? What I am missing here? I missed this from this importing module. So what should I do now? Go and import the module. Save it. And then run module. Got it right? 15. The same thing, how you are going to implement with lambda? That is the next question. How you rewrite this with the which one? Lambda function. Simple, right? Can you see there? Lambda function works so simple. Just pass two parameters, just simply say x plus y. Okay, that's how lambda behaves. Understood now? So simple differences here. You want to apply same logic with lambda. You don't need to write all this stuff. If you want to finish it with most optimized approach, directly go to the reduce, go to the lambda space. You have to take two parameters this time, not one parameter, some a comma b colon. Then you should say a plus b. See, internal, exchanging elements from B to A, C to B, something we have done it right in the previous thing. That is automatically taken internally. You don't need to worry about it. That interchanging of values from one variable to another variable is taken care by the algorithm itself. Don't worry. You have to pass perfect logic here. Now run it. We should get same 15. Then we are good. If you get anything else, you are bad. Okay. then you have to be a dad for that program. Means again you have to recreate and then do it from the beginning. Something you have to fix it. Got it right? Any questions on this? Are you following, guys? Are you following? Following, folks? Is it clear to all of you? Say yes, no.
Yes, yes.
Shiva, I have clearly explained lambda in the earlier session. So yeah, that's what Shiva. We had a detailed discussion in the last class. Okay. So why don't you go through that session? It is there in the YouTube. 15th session or 16th session in Python. Okay. Got it right? We had a very detailed discussion in the previous session. Okay.
Actually, sir, I'm Satish.
Okay. Tell me.
So, how the values are reassigned?
See, every time, if you have understood the previous one, you understood this. If you have idea about, you have got clarity about this logic. The same thing we are just rewriting with lambda, nothing more. Understood or not? Internally, what happens? So here, you just print these values and print this AB. You get a clarity here. I'll just show you now. You want to get a clarity, there is nothing. Just understand the algorithm. Print A, comma, put some space, comma B. Then you get clarity like how reduce is working on these values. Okay. Now format run module. Again, same thing. Of course, I missed something here. What did I miss? Somebody is asking me question, Shiva or somebody. I'm just give me 2 minutes time, guys. Let me give him clarity. Okay. Now, Shiva, let's save this. You have idea about Fibonacci logic, right? Do you have idea about Fibonacci? Yes or no? I'm waiting for your answer. Okay, then. Shiva, then you do one thing first. I suggest you, what you do, first understand the logic of Fibonacci. Then you get clarity like how the exchanging of elements happens here, okay? I think I taught that Fibonacci series example. Somewhere it is there in my channel. You can go and check that, okay? So first it will take 1 and 2. It will add it. Then it will take next subsequent elements. 3, 3. Then it becomes 6. That will be added to next subsequent element. It becomes 10. That will be added to next subsequent element. That will be 15. If you have a clarity on Fibonacci logic, then this is almost a similar logic here. If you don't have idea about Fibonacci series, or if I didn't teach that, then I will show you how to do that. Okay, nothing to worry on that. All of you have idea about Fibonacci series? Say yes or no, guys, so that I will decide whether to explain it now or not. Okay. Okay. Only Ayappa is saying yes. What about others, guys? Do you have idea or you don't have idea? Please, can you confirm? Okay. Still, few more. Vinod said no. What about others? Only Vinod and Ayappa are there in the session, I hope. Huh? What about others? Are you good with Fibonacci? Just tell me some answer. Oh, no idea. No, sir. Okay. Still about others. I got more no's here, so I will explain Fibonacci series. Don't worry, because your clarity is more important. Okay. So let me quickly explain. So let me finish this first and then explain Fibonacci how it works. It will take 5 to 10 minutes. Then you get clarity on this, how the exchanging of elements happens. Okay. So that's what it's a kind of Fibonacci logic, and you have seen the output as well, how it is working. But still, so that's how reduction happens. When you have group of elements, the reduction happens like this. Okay, but as you are saying that you have a problem, like you don't have issue, you don't have clarity on this. So what I do is I will explain clearly one more time. This is how the values are reduced. You take first two inputs, basic 1 and 2. The reduction behaves internally. Reduction is using a kind of Fibonacci logic. What it is using? Kind of what logic? Fibonacci logic. What it does is it will take first two basic inputs. From that it will be adding those two, and the result of that two inputs is added to the next element. Result of that, these two and another element, the next subsequent element, these two become input for next iteration. Again, when you add this, you get some result. The output of these two plus the next element will become input for next iteration. Again, the output of sum of these two plus what? The next subsequent element will become input for next iteration. Okay, are you following or not? Yeah. Following, guys? Means this is how the internal logic works. Got it right? So this is how the logic works. Now, once that is done, every time it is added, one value will be returned to this function, to this reduce. That again, what happens? Reduce will keep passing two parameters at it every time. What parameters? The sum of the inputs plus the next element will be again sent back to the function parameters. Are you following this? Okay. Now let me run this. You get 15. I have shown already. Next after this, okay, lambda. How lambda works here? Somebody is asking. Lambda also works on the same principle. LambDA. Okay. It should take two parameters, x, y, and then x plus y. The logic is this. Exchanging of elements happens internally. Again, what you do is you can remove this. Okay. Got it right? Now, when you try to execute this, maybe if you understand the function, a similar functionality happens with the lambda also internally. Same whatever we applied on this. You get 15 here. But anyhow, if you want to get clarity on how this internal value jumpings are happening, first it will send what two elements, even same thing. First two elements, somebody is asking, right? 1 and 2 are copied to xy. Then addition is performed on x and y. Same thing. Okay. Then what happens? An addition is performed on x and y. Okay. Then what happens? That is the output. Now again, what reduce will do? It's like this. Let me show you. So if your logic is this, what is that? X comma y colon x plus y. What is the behavior? First 1, 2 are inputs. It becomes 3. Same thing. Now it get 3 as result from lambda. Now what reduce will do? It will take 3, next element in the iteration 3. It will send again these two elements as input. Now 3 comma 3 are inputs to x comma y. Somebody is asking the analysis, right? I'm explaining. Now how much this happens? 6. Now again, Lambda returns a 6 here. Now again reduce, what it will do, it will take 6 and the next element in the iteration 4. It will pass 6 comma 4 as input to lambda function again. Lambda takes what, 6 4 as an input and apply addition. Okay, 6 plus 4 how much? 10 plus comma next element in the iteration, in the sequence, sorry, our iteration is also fine. These two as inputs. Okay, again what happens? So 10 plus 5 how much? 15. And do you have any subsequent elements in the list? Are there any more elements to iterate? No, this is the last. 5 is the last, so it will return that total result. Now when you print it, what do you get? You get 15. Is it clear, Shiva, now? Okay. Shiva, that is the behavior of reduce function, not lambda function. Okay. Lambda doesn't have anything to do. Lambda just does the addition of two numbers. Okay. You are asking a question using lambda, how can we pass the expression result as first argument to lambda function again? Okay. So lambda doesn't do that. Reduce, that is the algorithm of reduce. Reduce has to take care of it. Okay. Do you understand it now? I think you say got it now. Okay. Clear, right? So go to run and just say run module. You got 15. That's about all these functions, guys. Successfully we have closed the very important functions of Python. Got it right? Next one. Aliasing, function aliasing. This is a very simple and not that demanding topic, but still just have a quick idea. I'll finish it within a couple of minutes. Aliasing is nothing but giving other name to the existing function, so that even though we delete the original function or the actual function, still it is referred by some other name, and that is what the advantage of aliasing. Okay, so for an existing function, we can give another name. It is nothing but functional aliasing. Even we have Chinni, Bajji, Buddi, or what is that, Bunny. Okay, all these names at homes, right? These are all alias names. You have some Madhu name, okay, but at home they might call him as Bunny. You know, right? That is alias. Okay, so now the point is, you just this, now you know how to create functions, right? We have a very detailed discussion about functions. Okay, what you do, just define a function, simple function with a parameter, just then assign F1 tab. You have to keep practicing all this, sir. While I'm explaining all this, along with me, understanding this is important. Also, practicing with me is important. Okay, I'm trying to execute it, right? If you want time, you just tell me, sir, I need some time. Got it, right? So I'll wait for you. Understood? Right. So now I'm talking about something here. What is that? Take a function here like this, simple function, and this is aliasing. Already you have F1. I am assigning the reference of F1 to F2. Means copying. All these are objects, right? Even function has address in Python, and the address of function F1 is copied to F2. That's what I'm doing here. That's why I'm printing ID also. And I can pass two things here because this is a parameterized, and my wish is to pass a string, so I am passing two names. One is Manu and one is Malvika. Okay, so that is functional, yes. Got it right there. The advantage is you can call with any names when you go for aliasing. Okay, this is a simple topic. It's not that challenging as well. Okay, So you can, I'll just show you now here. If you see, you can take one function df f1. If not name, you can take any parameter. Then you can just simply say print of name. Then you take f2 equal to f1. You can practice it with me. Then you can call it with any name. You can say f1 of okay, something like Manohar, or you can say f2 of okay, Vedant. Okay, you can call with any names, guys. So just save it and say run module. Okay, you got it right. Don't worry about the spellings, typos here. Okay. Now I am able to invoke this function. Invoke means call it with any name. How? Either with the f1 or either with f2, because that is what aliasing does. Suppose if I delete the f1, how to delete these objects? This has address actually. If you want to check the address of each function, you can say id of f1. And again print id of f2. You test this. You can test it and see your results. Okay. You know, you can see both have same ID. Why? Because you are copying address of f1 to f2. Obviously, both will point to the same address. Okay. Next one. Got some idea? Sir, got some idea or not? Suppose I deleted f1, the del space f1. You know, I told you how to apply. This del is universal. You can apply on anything. You can use del keyword to delete a function object, a string object, a list object, a tuple object, or some elements from map or some elements from list based on index. You can use del, that is an universal delete function or delete key command which we apply in Python. Okay, remove certain functions are there, they are specific to the API of that collections itself, but or some other class itself. But del is not like that. It's a command applied on anything. Okay, so just run it. Even though if you delete f1, still we can have access through what? I'm just, let me just test it one more time. I can still use a f2 of something like okay, something. I'm just writing some module here. Okay, right. Now let me run this. Got it right? I got Madhu. Why still? But that ID of f1 doesn't exist once you say f1. Del f1, f1 will be removed. Got it right? You don't have still there, but still I am able to invoke that function through aliasing. So this is a simple idea about what is that the concept of aliasing. Do you want to test it? Take 1 minute and test this code. Okay. Any cases, probably usually, you know, if you want to point to the same function with multiple references, okay, just to preserve the original object, not to, what is that, to make it, what we can say it is, if the same functionality, you want to run it in different scenarios, like, you know, best example is a string value. You take a string example, same string will be referred by multiple variables. Got it right? And then what is that? The advantage is this is a kind of concept related to immutability. So that if you modify what is that? The disadvantage is in immutability concept. What is that? You cannot directly modify because you have an impact of one object on other references. So what do you do when whenever this kind of functionality comes into the picture, let me clarify it. When same function object has to be referred by multiple parameters in different use cases, so that you can call according to the requirement of names. Okay, you can name it as per the requirement. That is a scenario. Might be if you go through the string immutability concept and if you try just go through that topic, get some idea. But coming to this functionality, this function, like function aliasing, to be honest, I didn't seriously used it. Aliasing is something which I didn't applied in most of my cases because that situation didn't arise. But might be that is a useful use case. Okay, just have some idea here because certain things we come across only when you have that requirement. But that requirement, I didn't get it so far. Okay, nothing. Got it right? Next one. So that's about aliasing. Function decorator, you can just have a quick idea about it. Function decorator. What is this decorator? This is a very important topic. So why do we need decorators? And what is the advantage of decorator? This is very useful and very deeper concept actually, but simple also, not something difficult to understand. What is here? Decorator is a function which takes a function as argument and extend its functionality and returns modified function with extended function. You don't understand anything from this statement, right? So what function decorator does? So it's something like this. You have a function, you want to modify that function, the functionality of that function, without actually directly going to the function and modifying it. Got it right? It is something like this, a quick example to understand it. Suppose it's like a mirroring concept. You ask someone to touch you, but it should not happen directly, but they have to, that you have to make that kind of approach. How do you do? You put a mirror opposite to you, and then what they can do, they can touch the person in the mirror. It's a kind of what you are doing, you are trying to manipulate it something. That is what decoration is. Decoration means, suppose the another example, already there is a function, you are extending the functionality of that function by adding something to it, not directly but indirectly. Suppose best example of the meaning of decoration itself, you take it, already there is a house, to that you are adding some decoration, you are extending the functionality, but still actual house will be like that, but you are adding some additional functionality through some decoration, isn't it? That is what decorator is. So the point is, now you can understand, decorator is a function and it takes function as argument, same like filter or reduce. Here also decorator takes function as an argument and extend its functionality. What it does, it takes a function as argument, and that functionality of that existing function is modified without modifying the existing function. If you see, okay, we'll see with an example now. Is the point clear now to all of you? Let me clear one more time. One more time I'll repeat this, because the statement you have to understand clearly. There is nothing in the code, but if this definition is not clear, then you can't understand decorator. If definition is clear, there is nothing in decorator. 2 points. Shall I explain now? What is decorator? Decorator is a function which is nothing but which is used to extend the functionality of existing function without actually modifying the functionality of existing. Decorator function will add that extended functionality. Got it right? Huh? Got it or not? So let us see a small example. You can see here what it is saying. Decorator is we can extend the functionality of function without modifying the actual function. Now, first of all, second thing, this is a decorator. Decorator means if you want to apply a decoration, something must exist for that, right? Yes, sir. Suppose if you want to put a makeup, to whom you apply makeup, some person must exist or not? Tell me yes or no. That person is the actual function. This one, something like this. That is original function. On top of that, you are applying some decorator. Means that is extended functionality. You following? Means you don't modify this original function. Means when I apply a makeup, am I modifying you? You will be same, right? When you remove makeup, again you are the same. But you don't modify the existing. But what decorator does, it will extend the functionality. Means you are adding something more to that. You can see that this is original function. You don't change this. Without directly modifying existing function through decorator, you apply some change to that function. That is what decorator is. Is it clear to you? Following guys. Following? Sir. Right. So now, actually, these decorators we use more in more with some built-in functions, built-in classes. Okay, and most of the time decorators are built-in decorators. It is very rare that you go for customized decorators. And soon when we go to the OOP concept, object oriented, when you try to work with the static methods or some other kind of methods, they apply a lot of decorators there. On top of functions, they apply decorators. Then you get some idea. You remember this topic when you switch there. Okay, shall we get clarity on how decorator works now? Suppose this is simple. This function everybody can understand because this is a very basic and very fundamental function. Just a function with name as parameter saying hello, some person name and good morning. So what I am doing is just a small change. I am just extending the functionality to this function without actually modifying this by using this decorator at the red decor. It's not like you should use, if it is a decorator, we should use decorator. Decor. You can give any name of your choice for a decorator. You can put X or Y or Z here. But make sure that if it is a decorator, on top of a function, we have to call it by applying at the rate symbol. That is very important. Now I am implementing a decorator function here, which takes a function as parameter. It doesn't take a variable as parameter, but it takes function as parameter. Repeating. It doesn't take a variable as parameter, but it takes function as parameter. Are you following or not? That is what I told you. Follow the definition. It is a function which take a function as argument and extend its functionality and returns modified function with extended functionality. Now you should be clear. Now you should be clear. Suppose if makeup is a functionality, I am sending a person to makeup man. Then what he will do? He will apply some makeup. Means here he is extending some beautiness, and then he will return him or her to home. After coming with makeup, you look pretty good, isn't it or not? Why? Because a makeup functionality is applied on you. That is extended. Same thing here. You pass a function as parameter, and there is an inner function here. Inner means function within function. The next topic is that only. We'll talk about that as well. Now, as this is a function itself as parameter, now what you are doing, you are passing, this is our function. What this inner function will do? Inner function will have direct access to this, to the parameter of this function you are passing. Now you are checking through inner function because already the function which you are passing f1 has a parameter name. That name can be directly invoked by inner function. Inner function has access to the parameters of to this function which you are passing. Means what is that function f1? Function f1 has a parameter name. Now you are checking on that. What is that inner? Suppose I'm passing name here. If name is Mano, say that hello Mano, today it's raining. I'm extending. If it is not Mano, then you directly print good morning. If it is Mano, if I am passing Mano, only in such case I am modifying. What is that? Hello Mano, today it's raining. Are you following this? Means what I am doing? By default, this have a function. Just an idea. That's all. Okay. If it is not raining or if it is raining, that doesn't matter. Just a clarity. Just an idea about how this functionality can be extended. You can apply this for logic also, a business logic as well. So I'm passing a parameter here. If that parameter is a Mano, then what is that? Then I am asking to tell that it's raining. Other than Mano, if you pass anything, the original function has to be called. Are you following? Are you following? So means what? I am adding an additional functionality here, saying that what is that? If ever, whenever there is a name Mano coming, then you try to add that to the existing function. Else you return actual function. Don't if any other name comes, just don't make any change. Just use it as it is. Got it, right? Let me run it and give better clarity. This is one important thing to need to understand. Okay. So this is one concept. People keep telling in the syllabuses. So decorators, generators, iterators. This is a concept of decorator. Keep in mind. Okay. One of the very important concept. Now let me run this. And let me show you the execution flow, how it happens step by step. Okay. Now what you are doing, the original function is this. When I pass Mano, what do you get? What is your output? Hello, Mano. Because I know that it's very straightforward here. So that's why I'm saying Mano here directly. Mano, today it's raining. If it is Vedatri, I get hello, good morning. Let me run this. Can you see this now? Means, did I modify directly anything to this? No. What I'm doing now, I am applying a decorator. First, when I call Mano, okay, what happens if I call Mano? First, what it will do is it will go to the function here. It will go to the function. It will see before going to execute this, iterate this. It will see the decorator here. It will check whether decorator exists. Suppose if any decorator exists, then the control move from function to the decorator, means it will come here. At the same time, this whole function, which one? This whole function f1 is passed as a parameter to this. Means that everything is an object. Just now I have discussed. The address of this function is passed to this. Now, definitely in a decorator, an inner function is required to extend the functionality of existing function. Now this inner function should have the same parameter, whichever you are passing as a parameter to existing function, to original function, that should be a parameter here also. So now you took the same parameter, means as the object is already there, it will internally take that, it will, your interpreter will check that whether it is having same name or not. Then what is that? If name is Mano, now you are extending functionality. Suppose if name is Mano, then you are adding this. Else you are asking to return the original function, same function. Function of name means same functional object. Now finally you are returning back the inner here. Okay, once after extending, you are saying return inner, and that inner object is returned to the result. Okay, are you following this? So here, what is that? If your name is Mano, only in that case you are adding this functionality. Else you are calling again. You are again calling back the original function. What you are calling f1. Func of name means you are calling this one itself. Okay. Is it clear now? Now what do you do? Go here, run module. You can see here this one. Clear or not?
Sir, Ayappa here. I have a question.
Yes, Ayappa, please.
In the Decker, we're passing the function as argument, right?
Yes, exactly.
The function name should be f1, right? How does it know that when you defunc, how does it know it has to refer to the f1?
So this is a concept, right? This is a parameter, right?
Correct. Let's say I have another function f2 of name.
Okay. The point
So
is
how,
simple. Yeah, it's a simple thing. When it is a parameter, parameter name can be anything. It is not necessary to have f1. Okay. You have idea about parameterized functions, right?
yes, correct. Let's say I have another function f2 that is also has the same argument name. So
That is
if
also
you
having
same argument as name,
okay.
let's say another function f2 under the f1.
You want me add to one more?
Yeah.
Okay. Okay.
f2 of name and same thing. You can print statement or something.
Okay. Fine. That is fine.
So in the Decker function, here also if you have the at the rate Decker on top of f2.
Exactly. Every function should be applied with a separate decker. The above one is not applicable for this again.
Okay, so if you have the another Decker function here on top of that, so how does they know which Decker is referring to which one?
If you have another decker,
Yes.
if you have another decker, then you change the name, right? See again, if you want another decker, then you say def decker two.
Decker of
You give it other name, right?
okay, I understand now. So the Decker, so here on the on top of f2, so the Decker function should be at the rate Decker2.
Exactly. So if you want a different functionality, you got it right.
Okay, I thought the at the rate Decker should be same for all the functions. So I thought how can it
Suppose
refer?
let me tell you. Let me tell you like this. Suppose if you want same functionality, you can directly say at the rate decker here. Okay.
Okay.
Now what happens, sir? First this deck when you come to F2, you are calling F2. Suppose let me see, tell like this. F2 of something like Ayappa. Okay.
Mm-hmm.
If it is Ayappa, what do you get now? You get good morning only, right?
Correct.
Yes, sir. Because this is common for all functions, right?
Yes.
This extended functionality is same, but what changes the original function differs. Okay. So
Okay.
that is fine. Okay. F2 of if I say Mano now, okay, it has to match it. Then this time what do you get now? You get hello Mano, today it's raining, right? Okay.
Yes.
Analyze this first. So you are calling F1. If you are calling F1, this control goes to which function now? Please tell me.
But first it goes to f1.
It goes to F1. Yes. Then
So
before
then
executing
it goes.
F1, what it will do? First, it will check it has decorator or not, isn't it?
Yes.
If it has decorator, then this function argument, this F1 is passed as parameter to this. This name, this parameter name can be anything. This is just used to hold the reference passed by this one, this decker. Decker will automatically copy the address of this object to this. Okay.
Okay. I understand now. So if you are doing if you are having second Decker, so you name it as a different Decker. So it's gonna be Decker 2 or Decker 3 like that. So yeah, I
Yes,
understand.
yes. You got it
Thank you.
right. Yeah, there is another topic under this. Okay, nested deckers is also there. We'll see there. Okay, got clarity now?
Yes, yes.
This is a
Thanks.
bit deeper. This is a simple thing. I told you.
Function name should be same as the Decker name, right? So then only it can identify it.
Function name. Which function? This one, nah? This one.
The first function
Yeah, definitely.
the
Whatever
yeah
this one,
yeah
whatever you define, that you have to declare on top of
Decker
existing
Decker name.
function.
Okay.
That should be same. Any more questions? Because
I think that is what Ayappa also asking, right?
Yes, correct. I thought the @decker should be same for all, but it's not like that. Okay, we refer to that name actually. Understand?
so I think his doubt is clarified.
Yes.
I think that's clear, good, right?
Yes, sir. Thank you.
Okay. So are you clear with Decker now? Decorator is clear, right, for all of you? Okay. Last topic, nested functions. Just say if anybody has still doubts, I can explain one more time, guys. I have patience. Any more doubts? Should I repeat? Should I repeat?
Can you please go to that program?
Who is it? Can I know
One
your
second.
name?
Madhu.
Madhu. Okay, fine. Yeah, Madhu. I'll go here. Okay, it's easy to analyze. Okay.
So, bro, I have small doubt here. So we are calling that so under the Decker we are calling that Decker, right? Decker function, and then that inner function is there, right? Defer inner name. I don't understand why it is really required. So because here we are taking function as an argument. It means F1 name. Again, why they are using that inner function? Instead of that, they can use directly that name, right? Because we are passing whole as a function to that.
Exactly. The address, the object comes here, but the purpose of inner functions is you are extending functionality, right, Madhu? What is the purpose of decorator?
Yeah.
What is it?
Simply in simple words, so on existing function, we are decorating something and giving it as output. It means,
Okay.
so I think you can make sense, right? Yeah.
Simple. See, on existing to an existing function, you are adding additional
Something
functionality.
to it. Yeah.
Some
That
you
is
are
what I
modifying
understood.
it without actually modifying the original function. Clear, right? And who does
Correct.
decorator? Isn't it or not?
Correct,
Usually,
exactly.
it's a standard approach in decorator to have an inner function. You know why? The purpose of inner function is it will modularize your code first thing. What inner functions does? It will modularize. Second thing, decorator definitely needs an inner function to add that extended functionality. I am making very clearly, I am explaining. To add that extended functionality, it needs that inner function. Now, what inner function does? You are passing some function as a parameter. The same parameter which you declared here, it will extract that here. How does
That is that's what actually I also have a doubt why they introduced it. Same, so they are taking as an argument name. You got it, right? My question.
I understand your question, but just if it is just only, this is only reference here. Suppose Madhu, if I print it, let me show you. If I print it, print of func, okay. Let me just run this so that you get some idea. Okay, leave this F2 here because we don't need this. Okay, run it now. What you are getting for when I print func here, this is func, okay. If you see the output, Madhu, observe it carefully. What I am getting there?
So address of that function.
How do you directly invoke address? You have to do somebody has to call it and try to do some change to that, right?
Yeah. Bro, can you instead of that func displaying of that func, can you try to display name? Will it works or not?
Can I display what? Name?
Name. Yeah.
Not directly get name here. I cannot directly get name here. If you want, shall I print name? One you are asking. Okay.
No, there only. So the first, the print function.
Here
Yeah.
you don't have access to name here, Madhu. You cannot have access to name here. It's not possible. Your inner function will try to invoke the parameter from this address. That is an internal communication. If I put name here, let me run it. Okay, as you are asking me, let me run it and show it because you get some clarity. You are going little deeper, no issues. You got an exception now, right? Can you see?
Yeah.
If you directly try to get this func is just an address. How can you try to get parameter from address, Madhu? There should be some mechanism, right? So that
Okay.
is done with through inner function. Means decorator definitely needs an inner function. Directly you cannot play on this address.
Okay.
Got it, right? Because this
Yeah,
is coming,
got it.
is passing this whole function as a parameter. Then in that internally holds some parameters, and that if you want to extract that parameter, we can do that with the inner function. How do we do that?
Inner function.
When I pass a parameter here, the parameter of original function, internally it will try to communicate to this. That is an internal process that is taken care by this application, this functionality, Decker. Okay, you don't need to worry about it. How it is coming, okay? But when I take an function and pass a parameter, this parameter is nothing but a parameter of the original function. Are you following?
Okay.
And how do I get access to this? Means I am passing that as a parameter here. The original function is passed as parameter to this. Whenever decorator is called, this decorator will pass this f1 as a parameter to this. Okay. And then internally, when I use inner function will communicate to this existing function and get that name. I'm passing exactly same parameter which is having a for original function. See this. Got it, right?
Okay.
So now you print it. Now on top of that, you are doing some change. On top of that, you are modifying it. Following, Madhu.
Yeah.
So you got clarity, right? If I put name directly here, can I have access to name?
No. Yeah, I got it actually.
Understood now?
I think yeah, so they might set that standard size. Yeah. So if you wanna
That is a
make use
standard way
that,
of
yeah.
that is a standard way of implementing decorators, Madhu. You need an function whenever you are dealing with the decorators. And the parameter of original function should be passed to this inner function.
Okay. That should be same, right? That should be same.
Same. Let us try asking me one more. Guys, I think we are not boring you guys, right? Those who are, others who are in the session. Is it fine for all of you? Okay. Okay, then see here, let me try to change this parameter name here. Usually I remember this parameter name and this parameter has to be same. Okay. So if name one equal to Mano, let me try this now. And function return name one. And then run module. Okay.
Yeah, got it. Maybe, yeah.
Yeah, let me, okay, means of course parameter name can be different. Parameter name can be different, but what is the point here? What is the point,
make
Madhu?
use that parameter, inner function is required.
Exactly. To make use of that parameter, you can use what? Inner function. Suppose if I pass one more, if I try to get one more, then you get error this time. Suppose it is something like name2 without having those parameters defined in this function. And if you try to take two parameters, you might get a error. Got it, right? Let me run and show you. Got it right, Madhu? Means
Yeah.
inner function is totally depending on number of parameters of which function? Original function, actual function.
Yes. Yes. Actually.
So that name, that parameter name is your choice, or this function parameter name is your choice, but the actual number of parameters should match. Clear, right? And Shiva is asking a please remove
Yeah, you
name
said.
equal to 1.
Yeah, you said. So that inner function always communicate with that main function and
Exactly.
picks that argument. Yeah.
Exactly. That's what it does. Shiva, if I remove this, Shiva is asking a question. If I remove this Shiva, then there is no point of writing a decorator. There is no, what do you call, there is no meaning of, going with decorator Shiva. Got it right? Because this is an extended functionality. If I remove it totally, there is no use of decorator. Then what is the purpose of decorator? You can directly call this function, right? Got it, Shiva?
Sir, yeah, I mean removing the def inner line, not the logic. Just
Which
I
one?
will add that if name, I will use that if name equal to Mano, I will return a value instead of defining a function. I will directly write the logic like if name equal to Mano, I will return a
One minute.
statement.
I'll come to your question. Okay, what should I do now? Tell me, please.
Can you remove that second line? Second line,
Print or the sales partner.
no, the def keyword, the second line, starting with def keyword.
This one?
No, def keyword, starting with def inner keyword. Yeah,
You want me to
that
remove
one.
this?
Yes.
No, you get error, Shiva.
Even if I return also, I will get okay. I cannot
You get
return.
an error. No, because you
Okay.
cannot have access to that parameter. That's what the discussion is with Madhu also. If you that inner function internally will try to extract the parameter from this original function. Internally, it will communicate to this original function and get that parameter from original function. Got it right? If you remove this, what happens? You get an error because you don't have direct access to name without inner function. Got it right?
Okay.
You are not passing variable as parameter here. You are passing function as parameter. You have to remember that.
Okay.
Got clarity or still any confusion
Yeah,
there?
yeah. Got clarity.
If it is a variable, then you can say if name equal to something, do this, or if that variable equal to something, do that. But this is not variable. This is a function. Then if it is a function, definitely we can have access to the parameter of this function through inner function. Got it right?
Okay.
That's what.
Yeah,
That's
I
the
got it.
Madhu's discussion is also almost the same thing. Understood?
Yes, sir.
So that's idea about this decorator, guys. Shall I switch to the next topic? Shall we move to the next one, guys? All of you are good now? Okay. Still, if you want me to go deeper, we can discuss. But I think we have almost had a deeper discussion on this. Okay, next one. Nested functions. This is a simple topic. Nested in sense function inside another function. Did you test this, guys? Did you test this function? All of you. Did you try decorator now? Try this example. Test it once. Take a minute and test it. It's good to understand the behavior first. As I told you, guys, these sessions will complete. These sessions will continue. I am not going to stop it anywhere because I have only, after working for 1 week, 5 days, in a hectic schedule. Sometimes what happens is to look after my personal things. I might be, I might not take sessions, but it doesn't mean that we are stopping sessions anywhere. Okay, I am committed to continue and to provide as much information as possible. Try this, test this once, guys. If you have, try it in your own understanding, like what you understand from that, you try from that perspective. Okay. Test it once. Finished it? If you have finished, then we can switch to the next topic.
This conference will now be recorded.
You can have a proper modularization with the nested functions. And that is one of approach of modularizing a code. Okay, nested functions is that. And second thing, you can see here now. I'm just simplifying it. I don't want to spend again. Let's close this functions topic. It's something same thing, like just take a outer function. Inside that you put some inner. You can see here. Same thing. Put it inside. The indentation has to come inside. And when you say return inner, the inner object is written. Okay, from outer you can return inner object. Okay, and again you can say return outer also. When you say return inner, this is return to which one? This is return to outer function. Got it right? Huh? So anyhow, we'll see one by one slowly. So let's try to understand this. First one, let us take a small example. You can try like this. Okay, even the inner functions can return values. Okay. Let me just you can just simply take a function return def outer. Name is your choice. If not outer, you can put f1, f2, and then def inner, something like this, and you can write. Usually we implement business logic. Here, just for a quick understanding, I'm just using some prints. That's all. Okay, print of. Okay, hi. How are you? Something. Okay. And then you have to call inner function from outer function. Means like this. Where is this caller? Where is this caller? Can you see this? Where did I put it? Is it inside inner function, outside inner function? It is outside inner, inside out. You can see this indentation. Both are at the same levels. Now from outside, first I should call outer. When I call outer, control comes to outer, then outer call inner, then inner function is called. Let's run this now. Can you see this? Hi, how are you? Got it right? You can also return inner function. Okay, you can say return inner. When I say return inner, then what happens? It is returned to outer. Okay, let's run this first of all. You didn't get anything, right? Why? Because this returned value, again you have to, it is returned to outer. Which function it is returned? Outer function. Now we have to again assign that to some variable in the outer. Okay, let me do one thing here. So I'll just say some result equal to outer. Now run this, and now means what is the return type of outer here? Can you see this? The return type of outer is an inner function. Are you following or not? We have discussed functions, right? Generally, if you want to return a value from a function, what you do? Return some a, return some b, you do that. But if I say return inner, means what? This outer function is returning inner function. It is not returning a value here. It is returning a function that you assign to this variable. Now result doesn't hold a value. It will hold address of inner function. Now what you have to do? Suppose if you want to, if you print result, let us see what happens. It's a common sense, folks. If you print result, result will print just object of that inner function or address of inner function, because that is what, can you see this? This is, it's saying dot inner. It's very clearly, no, it is very clearly showing here. Then how do I call inner function? Don't do anything here. Just simply make a call, put parenthesis, then inner function is. This is another way. Can you see now? Means through outer function, you can get inner object, and you can call inner function outside outer also. Outside outer function also you can call inner function. But for that, what you have to do? Your outer function should return inner function that has to be assigned to some variable, and then you have to call from outside like this. Got it right? Clear? Clear or not? Following or not? That's what, you know, just now we have discussed decorators. Just now we have discussed decorators, you know, right? In the decorators, we have used inner functions. Now this is how inner functions behave. Now you can get better understanding. Go and look decorator now. This gives more idea. This time you get more idea. What do you say, folks? Yes or no? Is it clear now? Say some. Tell me yes or no, sir, so that I can explain one more time, or I can switch to next discussion. Okay, next one. So other things are same, sir. We are almost done with this topic. The other, then we have switched to encapsulation. Took some samples, but it's fine. We can test it later. Let us close this here. This is another example with the inner function having parameters. Even you can pass parameters of outer to inner also, sir. Okay, another example. I'll just show you quickly. Suppose I want to find sum of two numbers from inner function. I take a, b here, sir. A comma b. The same parameters I can pass to inner also. Then I can apply a business logic here. I am just directly doing it, sir. A plus b. Now I call outer function, sir. I'm passing two values here, 1, 2. And those two are passed to outer, sir. And again they are passed to inner function. From outer, they are again delegated to inner function. What is the word? Delegated. This is called delegation. Now I am doing some and I am calling inner. That inner already printing is done inside that. Okay. Now you have to call it from outer here. You can say result something like this. Then quickly say run module. Then inner missing two required positional arguments a comma b. Okay. Is it expecting elements from here or what? Okay. I'm sorry, guys. I have to pass values from here, right? Can you see here now? Variable names can be different. Don't think that. Here you can put x comma y. These names can be different because these are coming from this caller, and here you can have local parameters. But when I'm calling this parameterized inner, then it should be this is a caller, sir. If this is caller, this caller should pass two values a comma b. Following now? Why I got error? Inner function is a parameterized. When you are calling that, you have to call it by passing those parameters to this function. Any function with parameters can be called inner or outer, can be called only by passing the required parameters. That is the error I made. But now this is fixed. Now run. This time I am confident we get out. We got 3 here, but some reason type error. What it is saying, object is not callable type. Which is not callable type. Yes.
That res is there, right? I think it is not required. Yeah.
Which one saying this one? Huh?
Yeah.
Return inner. 1 minute. Give me a minute. Is returning regret return. Okay, let me run this. Okay, that's it. Because this function is called, and fact directly it is what is that? This is not actually even. I don't think 1 minute is returning. But as I am directly printing it, the function, we don't need to return result. Let me try this. Got it right? You don't need to even assign to that additional variable. Got it right?
Yeah.
Because this inner function is not returning. See, when should we assign something to this extra variable is if inner is returning. We are just saying return inner means it will just print. It is just printing inside. As it is printing internally, again you don't need to initialize anything. No need of even that result also. Madhu.
Yeah. With the help of that return statement, we are calling that inner function. Am I right?
Exactly. Yes. Actually, we can call it like this. Even this doesn't make sense now. See, you should put return here. Usually, you should put return here. If your inner function is returning something. Are you following or not? Madhu.
Yeah.
See, if you are directly printing here, there is no need of saying return here. You can directly
Correct.
call
Exactly.
Okay.
Yeah.
Now done this. Now outer will call inner, passing parameters from outer to delegate parameters of outer function to inner. Then they are passed to inner function, and you are printing it, and just please printing that side. Got it? Now, when should an inner function should be returned? Suppose I say that here. Suppose I say return x plus y. Now, what inner function is doing now, folks? Inner function is not printing the result inside that. It is returning result. Then now I can return this result directly to outer. Now this makes sense. Now what I am doing, when inner returns a result, I am returning that result of inner function to outer. What is the return type of outer? the result of inner function is the return type of outer function. Means when I say inner here, it is not returning inner function, but the result returned by inner function is returned by this. It is like that famous Swamiji is there, right? Who created his own country. Forget his name, Nityananda. He says, my you is this you is that you, like that. What is the point here? The inner function is returning that returned value of inner function. If you want to return to outer function, then you have to keep it here. Are you following, guys? Are you following or not? Now, what should I do now? What is the return type of outer function? Return type of outer function is the value returned by inner function. What is this inner is returning? X plus 5, that is 3. Means you have to assign to some variable here. It is not returning inner function object, but it is returning the result of inner function to outer. So I can say result equal to something. I don't need any parameters. I just need to say print of a now run module. Got it, right? Do you understand what I am explaining? Folks, I have clearly explained. If inner function is not returning, there is no meaning in returning the inner object to outer. Just for only namesake calling, you can just call it. But if inner is returning, then you can return a value of inner like this. Okay, is it clear now? This is idea about inner functions, so you can play with them as you like. So with this, we have almost completed functions, folks. Oh, very lengthy topic. I think it took 2 weeks. Next week, we'll go ahead with the files and we'll see different lots of use cases which works in real time. Okay, if you have patience, I can keep on teaching you like how real use cases can be implemented. And then you can apply this on certain topics there. So whatever you learned here on functions, you can modularize with the upcoming topics. Okay, understood now? Okay, guys, we'll meet again in the tomorrow evening. Okay, not tomorrow morning. I told you, right? This kind of, sometimes, as the only time I have is weekend. So that's why, sometimes it might not be possible for me, but don't think that I am going to break it. We'll continue. This will be keep going, at least in the form of workshops. Good now? Clear? Okay, we will meet tomorrow 8, and tomorrow we might take up files topic, okay, and continue with files. Functions are done, Sandhya. We have finished with functions today. We have almost done function types of functions, default, parameterized, parameter types of functions like default parameters, positional parameters, and then variable or parameters, and one more type is there. We have discussed all that, and then we have discussed again. What else we have discussed? Exceptions comes in OOP. Exception handling comes in object-oriented programming, Ayappa. Okay. This is this will continue. This will take time, Ayappa. We keep on learning so many things. I'll give a lot of exceptions on files again. Okay.
So was that regular expressions or finished?
No. Regular expressions are still there. We need to discuss that as well.
Okay.
Okay. We just only finished some 70% of core Python. Still, there are so many things to discuss. Because we are doing so many problem solvings, right? Once we start functions, we didn't do much functions by much problems. But still, most of the time, what we are doing? Problem solving. That is taking time for us, but it's fine. No issues. See you guys.